Good to see you. And this is our first meetup of SF Cryptocurrency Dev. My name is Tarek Lewis. And my co-founder here is Nelly Mensah. Woo! Okay. So everybody who's self-selected into this group is a self-certified crypto nerd, and we welcome you and your nerdiness. So I'm just going to go through this quick presentation, tell you why we created this group, and why it is an awesome group, and this is going to be great. So Nelly and I got together and said, hey, there are a lot of meetups. Could we have another high-quality developer meetup like we did at SF Bitcoin Devs? And we said, hey, there's need for one more meetup. But all of us, if you've been here since 2013, 14, 15, you know that your interests are no longer just in Bitcoin, right? Your interests have exploded as technology continues to evolve. So we wanted to create a meetup group that allowed us to do the same thing we did at SF Bitcoin Devs, which was do really deep technical dives into the broader cryptocurrency ecosystem and not just Bitcoin. So, we're talking to folks at Zcash, we're talking to the folks at Monero, we're talking to oh my goodness, yes, exactly, just many. So we're going to try to do this twice a month. So this is a startup. The startup might crash, so bear with us. We're going to try to do these 2 times a month and make sure they're super technical and super focused. Wow, dude, welcome. Jeez, all the Bitcoin people. Okay, and we're just going to keep it technical. A lot of learning. So we want to be peer-to-peer. So the people you meet here, I can tell you, I know mostly everybody here. And so if you don't know me and you don't know the people here, everybody here most likely wants to learn and wants to share what they've learned. So you will absolutely enjoy connecting with folks here, so please do. And tell us what you want to learn, right? Tell us what new cryptocurrency software you're interested in. And we should be able to, look at that, tell us, come present. That's another thing we did as Bitcoin Devs. We had, the audience and folks who were working on projects present on them. We have a Discord that we're keeping mobile. So this is the first time we're trying to see, hey, after the meetup, if you want to keep talking, have ideas, join our Discord through the meetup group. Download the app. I'm going to let Nelly introduce herself quickly. So forgive me, Nelly, for taking up so much time. But you're going to see more of Nelly and less of me as we go through these. Yay! Because Nelly is just super awesome and super smart. So hold on, let me give it to Nelly.
Hello, everyone. I will keep this super brief. Tarek and I met after his time at MIT and right before mine. My interest in actually cryptography runs back to my days at Stanford, where I somehow happened to sit in on a cryptography course and thought the whole concept was fascinating. So when Bitcoin kind of blew up more or less in 2013, it piqued my interest. I've been following it since. I think this is a good time for everyone to step back from the frenzy and just kind of get to know what it really is all about and try and figure out what, get to the heart of the matter, explore the nerdiness of it, and get excited and chat. So please join the Discord. We want to engage. We want to keep all of our presenters engaged. You can ask them questions if you have any ideas for people we should invite and present, or if you want to kind of debate with each other. We really encourage that. But exactly. Welcome, and we will have our speaker just come up.
Wait, okay, who's this? NuCypher? Who's NuCypher? Oh, Michael! All right, let me just introduce Michael. Michael Igorov is, he's going to tell you what he does, but my history with Michael, he came to SF Bitcoin Devs meetup after getting bored at the Ethereum meetups. And he and McLean have been working on a number of crypto-related startups. I am super excited for them to talk about NuCypher's technologies because I've been sort of sticking close with the evolution of it as it continues. So the reason why I want you guys to really pay attention to this presentation is a lot of times when we think of cryptography or cryptocurrency software, it's very hard to make the jump from blockchain ideas, mining, staking, etc., crypto economy to a new real world application that is not necessarily about making money. It's not exchange, it's not trading, it's not some new sort of financial asset. this is one of the few projects that I have seen that actually has a real world application that doesn't require you to force somebody to trade money. And it's using all the technology you may know in blockchain and cryptocurrency. So, please give a warm welcome to the awesome presentation and presenter, Michael Igorov and NuCypher.
Thanks, Tarek, for the nice introduction. And yeah, so what we are actually doing, we're working on encryption, and we are making it possible to make encrypted end-to-end encrypted decentralized applications. So what TLS is for internet, we are making this for decentralized applications. TLS is transport layer security, so it's basically encryption in transit, which is happening today across the internet. Like when you connect to your bank or something, doing that from Starbucks, the dude next to you cannot see what you are doing, right? And the service provider also cannot see what you are doing, presumably, and only you and the bank, right? So that's what TLS is. Anyway, so why do we need to do anything special in the world of decentralized applications? So to explain this, I would probably start with some use cases instead of jumping into how it works. So imagine you want to, you work with, I don't know, Dropbox, right? And you want to share files with somebody, right? You stored your files at Dropbox, and now you want to share it with people. Like you just tell Dropbox to allow them access, and here we go, it works, right? Well, if you think about what happens under the hood, before you send files to some file storage, you encrypt them first, even with Dropbox, but in Dropbox it happens over the wire, so Dropbox can decrypt that. But anyway, you encrypt the files first, and then everybody who reads your files, who you allowed access to, gets some, encrypted stream before decrypting it. So, like, really, you send something encrypted over the wire, and people get something encrypted with a different key when they read it, right? Anyway, the thing is, like, how do we put something encrypted with your key and make like other people read something encrypted with their keys, and that thing is still your file? How do you make this? This is like one application. Another application is, let's say, multi-user chats, and I think probably everybody at least tried using Telegram or something with encrypted chats. When two people want to basically communicate privately, they let's say they exchange key pairs or establish shared secrets. And well, let's say simply when I send a message to one of you, I can encrypt a message with your public key and send it to you, and then you can decrypt with your private key. So so I don't have to know your secret key, you don't have to know my secret key, and we still can exchange messages. It all works well when you have only two people. Imagine some chat application which involves multiple people. So you send your chat message to some message board, and you need 100 people to read that. So what would you do? Like, one of the ways would be for you to encrypt message for every of the 100 people, right? So you do 100 encryptions for every message, and then when another person comes, you would need to encrypt all the messages. Well, first read all the messages and then encrypt all the message history for him. Not very convenient. So it doesn't really scale well. That's why I guess Telegram doesn't have multi-user end-to-end encrypted chats, only like unencrypted. So end-to-end encryption for situations when you have more than 2 people. This is kind of an unsolved problem. And another thing, imagine like you probably can imagine how Netflix works. You have somebody who sells video content, and you have some CDNs or some central server which distribute this content, but only when users pay for this content. It's all easy when you trust some central authority like Netflix, but how would you do that if you don't have any central authority and you don't allow anybody who didn't pay to see this content? So this is also like something which wouldn't work in like traditional scheme, which works for internet. So anyway, how do we solve all these applications in practice? Well, their traditional way always was to use TLS. So you would, every time you send your data to some servers, you encrypt it, and it gets decrypted at the place where the service is, at the server. And then the server encrypts for like whoever you allow access to, and they read the data. And this is all good as long as you trust the server. But sometimes you have, I don't know, some hackers, some, some state actors penetrating your server and reading your data maybe, or maybe not. Anyway, it's kind of tricky. So, and this is what all the decentralized world tried to be against. So not allow like anybody to control your money, your data, or anything, right? So how would we do that? So without explaining this, I'm just saying that I will go deeper after this slide, but here I'm just saying that we are solving that with a combination of something called Proxy-Reencryption and with decentralization, right? So, and firstly, I will explain what Proxy-Reencryption is. So, for that, I will probably firstly mention what public key encryption is. This is, and how it works for actually encrypting data. So, as when I want to send some data to you, I can encrypt data using your public key, and then you can decrypt this data using your private key. Public key is something not secret, private key is something secret. So I don't have to know your secret private key to encrypt data for you. This is how public key encryption usually works. And what Proxy-Reencryption is a set of encryption algorithms where you can allow some third-party service to transform data which were encrypted for you into being encrypted for somebody else, right? So let's say I have my files, they were encrypted for me, stored at Dropbox. Now, if Dropbox supported Proxy-Reencryption, I would ask Dropbox, hey, here is my special thing which is called re-encryption key, and this will allow you to transform data to be encrypted for Bob so that it's readable by Bob, and then the server can do this work and make the data decryptable by Bob as he reads it. So let's say usually in here, like before this transformation, you have some kind of storage. Let's say it could be Dropbox or could be decentralized file storage like IPFS, and then you could ask a third-party service to transform data for like whoever you share it with. I guess I can show a quick demo of like how it works hands-on. Can I? Okay, let's 1 second. Okay. It's weird. I see. All right. Okay. So let's say, okay. And when I will show this demo, I will if you've been listening, you will see some inconsistency, and if you notice that, I can explain what it is. But anyway, let's say you have two guys, Alice and Bob. So okay, lady and guy, right? So Alice wants to Alice stores her data in some cloud service or something, and Bob and then later on she decides to give access to Bob to read this data. So every of them, they have a key pair, like it usually is with public key encryption. So Alice's key is let's generate that, and let's generate Bob's key, and I guess I will make a public key for Alice, which is something which is not secret. Okay. Okay, and the public key for Bob, right? Oops. So when Alice wants to encrypt something, she uses public key, and when she wants to decrypt, she uses private key. She can decrypt only what is encrypted for her, and Bob can decrypt only what is encrypted for him. So let's say Alice encrypts some data. So let's say. Okay, we use Alice's public key. She encrypts for herself, and the ciphertext is "Hi, Bob." Right? I guess that should work. So the ciphertext looks like this, and of course, Alice. Let's say if Alice tries to decrypt her ciphertext, she needs her private key, and this is tricky with this microphone, and I guess this will work. So if Alice decrypts this ciphertext, it works. It's stored somewhere. Maybe it's some secret message. But when Bob tries to decrypt it, it actually doesn't work. Because Alex encrypted it with her key, and she didn't know originally if she wants to share it with Bob or with Charlie or with whoever. Now Alice decided to share this message with Bob, right? But she doesn't want to pull it back, decrypt, encrypt again with Bob's key. She wants to delegate all this work to the decentralized application or to the server. So what she does, she generates a re-encryption key from her key to Bob's key. Okay. Alice, Bob, okay, and we have the re-encryption key, and now she gives this re-encryption key to the untrusted cloud provider or like decentralized application or whatever. And what this application does, it transforms data with this re-encrypt method using re-encryption key, and the ciphertext. And yeah, it looks like it worked. And we've got a different ciphertext. Yeah. And now let's say if Bob tries to decrypt that, then it works. All right. So the let's say some untrusted server transformed message to be encrypted for Bob without ever seeing it. This happened right here when it did pre.re.encrypt. So this happened on the side of untrusted server. So we kept the message in secret from the server, but still managed to transform it. Oh, well, it was. Yeah, it took about a quarter of a millisecond. Anyway, so but now with this, just proxy re-encryption already, we could have a service which allows to handle encrypted data share with multiple people, but this would be, let's say, this would be a centralized service. And that's what we did originally before we started doing our decentralized network. And this was already pretty useful for some companies like banks and some other financial companies. I probably cannot say all the names yet, but anyway. So originally we did it as a centralized service. How it works? Let's say you have somebody, Alice, owner of the data. She encrypts your files and stores in some storage. And basically, later on, she, using public key of the guy who wants to read the data, she sends this, generates this re-encryption key and sends it to the proxy. So the proxy is working as actually something which transforms data which was not decryptable to be decryptable by Bob. So let's say Bob, the receiver, fetches the file. It's some data encrypted for Alice. He cannot decrypt that. But what he does, he basically sends it to proxy and gets back from the proxy something which he can decrypt. This wouldn't be very performant, so we actually have a symmetric key which encrypts the bulk of the file, and that is the thing which is made decryptable for Bob by proxy, and the bulk of the file stays the same. This is something called envelope encryption, and this works in a way similar to how key management systems usually work. But key management systems usually respond to the request something like, please decrypt this. And our key management system responds to a request, please make it decryptable by me. But that's pretty close still. Anyway, but this is still centralized. So let's say if imagine you did it for, I don't know, for Telegram Messenger, right? And then, I don't know, Telegram Messenger gets, I don't know, banned in Russia because it's obviously used for terrorism, and the government comes and shuts down the proxy, and then it doesn't work. So that's too bad, right? Same with when it happened to money, all the centralized electronic money didn't actually work. So so same kind of thing here. So we want to somehow decentralize this proxy so that it's impossible to shut it down, and it makes it possible for you to share data with everybody in encrypted form, regardless of anything. How we do that? We actually, with our collaborators in the University of Malaga in Spain, came up with something like split key re-encryption. So it requires collaboration of multiple proxies to transform data to be decryptable by you. If you have one or small percentage of proxies going down, that's okay. The data can be still decrypted by you. But if let's say more than I don't know, more than 30% of proxies decide to not re-encrypt, then you cannot get the file decrypted. So we kind of split the trust between all these proxies and make it so that we are okay with some of the proxies sometimes going down. Also, some proxy could become malicious. So let's say you share data with your mobile phone, which has a completely different key, and then you lost the mobile phone, so you decided to revoke the access, right? So you can ask the proxies to revoke the access, they remove the re-encryption key, and it doesn't work anymore. But imagine that you actually not lost the phone, but somebody like seized your phone, and they are very powerful, so they can kind of bribe the proxies. So we kind of bet on the fact that it's pretty hard to bribe like all the proxies. So if you manage to convince one or two proxies or three proxies being like malicious and transforming data when they should not, it still wouldn't be enough to decrypt the data. Basically, and to decrypt one file, we need collaboration of about 50 proxies. It can be any number, but like 50 is something we kind of decided to choose. And we want to trust these proxies somewhat equally, right? Well, fairly equally. So, and how we do that, we actually, the amount of trust to each proxy is proportional to the amount of our KMS token which they stake. So this is decentralization by proof of stake in a way. And yeah, so here we come to basically the necessity of some sort of coin for this network to operate. So in order to split trust between all these proxies, we need the coin, and they kind of stake this coin. If they start acting maliciously, the network detects that, and this deposit, kind of part of this deposit gets seized, so the proxies are incentivized to operate fairly. When they operate properly, they get rewarded for their operation. And yeah, so this token works to split the trust between proxies, to work as a security deposit, so that they work, the proxies work kind of fairly. Also, this token is used as like in-network means of payment. So you kind of need to pay to create the policy. Let's say I allow access to that guy for like 1 year, or then you pay for this policy, or I allow access to like whoever to this guy as long as he pays. I also pay for this policy a little bit. And yeah, also when initially we have some sort of mining schedule, so the new tokens are created and they are distributed like proportionally by proof of stake to to all the nodes who participate in the network, who do the re-encryption. So they do the re-encryption and they get all the newly minted coins plus fees. And I guess, yeah, so you this is all distributed proportionally. So however many tokens you lock, you get a fraction proportional to that, and inversely proportional to total amount of tokens locked with the mining nodes, and also you have all the transaction fees for the policies which you get re-encryption keys for. Right. So this is how the token works, and that's why it's needed, mainly for decentralization of the network. Now, if you can imagine what happens if some government actors who have a lot of money want to take over the network. It's possible to have a 50% attack here. If somebody gets more than 50% of tokens, or maybe actually more than 50%, maybe it's tunable, it could be 70. But anyway, if somebody gets more than 50%, they cannot decrypt the data, but they can transform the data, then they can keep the data available for like whoever you allow the access to. So the attack here would look like you would allow access to some guy, and that guy gets like hacked by the state actor, and state actor also controls the nodes so that they keep access to that guy who they hacked. So we don't want that. And in order for the state actors to take over the control, they should get actually more coins to get more coins, they should buy them on the exchange. If one state actor wants to get the control, maybe the other also wants to get the control, so they can probably start fighting for that, and that's going to be pretty exciting. So anyway, this is so this is you know, if it ever comes to that, if it ever comes to being such an important thing that governments care about that and fight to control that, it would be something similar to kind of a balance of nuclear weapons, but instead of creating nuclear weapons, they probably would buy coins, right? Anyway, so I cannot wait to see that happen. Is there and here are actually the users, the early users of our decentralized network who are pretty desperate to use it even before we launched it. So they are convincing us to develop it faster. And these are mainly like decentralized marketplaces, which like get to sell, like Datum lets you sell some your personal data to advertisers, I guess. Helios sells some analysis of DNA to pharmaceutical companies. They want to do that autonomously. Also, some decentralized databases projects appeared who want to use our network for sharing, for enabling multi-user functionality in these decentralized databases. And also, interesting topic of sharing medical data. Like these three companies give control over medical data to patients, and patients, so the patients encrypt their like data with their keys, upload to either IPFS or even Amazon. It depends on really like which company it is here. Some companies do one thing, some the other. Anyway, nobody can read this data until patients like really share this data with somebody, mainly with doctors. So this MediBlock company is doing that in Korea. ZeroPass, I guess they're spinning off some company with a different name, which does that. Do that in Europe, and Wholesome, which actually it's not confirmed with them yet, but they want to do that in the US. So that's pretty much the early use cases for the decentralized network. That being said, what we are doing is totally possible to deploy in a centralized environment. So some, consortium of, if a consortium of banks wants to deploy this on premises using some, private Ethereum blockchain, or even without a blockchain, they can totally do that, and that's in fact what we started from originally. So, and we do have some customers who want to do that. And basically, here is the team: 2 founders, myself, and the CEO McLean. I'm coming from physics background, even though after that I worked in LinkedIn on infrastructure tools side, so I did a PhD in physics of ultra-cold atoms. And McLean has like financial background. He worked at Morgan Stanley, and after that started working on tech startups. And also we have some good advisors. Basically the top 2 ones are cryptographers. So this Giuseppe Artenese, he's a specialist in Proxy-Reencryption. Dave Evans is a professor in University of Virginia. Actually, he has a pretty good online encryption course if you're interested. And also John Bentelman, who did backup solution Rainstor and sold it to Teradata. And also Tony Bishop, who is from Morgan Stanley, from McLean's connections. Yeah, he did infrastructure, built infrastructure for them. And yeah, so if you want to learn a little bit more, get involved, you can go to our website, NuCypher.com, or to our GitHub, which is NuCypher, or actually a lot of discussion of our development is happening on Slack, as well as you can subscribe to the announcement on the website or see them on Slack. And also, of course, you are more than welcome to read the white paper, which is linked on our website, or you can read it on archive. And yeah, that's pretty much it. And yeah, any questions?
That's a very interesting work, actually. So the miner here in this case is different from miner in the blockchain or Ethereum, right? Because your miner basically carries some private state, which is the re-encryption key.
Yes.
So I'm wondering, like, say
Yeah,
if
so
the miner goes offline, could they just relay this private state to the next miner?
Yeah, in principle, it is possible. We're considering doing that. But if the miner goes offline temporarily, that's fine, because we use split key proxy re-encryption, and we allow some miners to kind of to die temporarily. But if the miner decides to go offline permanently, yeah, then of course it's possible to transfer this re-encryption key. But for now, at least in the first version, what we want is to kind of make the miner to commit to handle re-encryption keys for a certain time, and basically the miners who can handle the re-encryption keys for long enough get selected when you deploy the policy. Okay.
Hi, thanks for your presentation. So in the demo, when you were showing, I didn't quite catch one part where you generate the re-encryption key.
Yeah?
Is Alice supplying the private key of Alice and the private key of Bob?
Yeah, that's exactly the thing which I deliberately left there so that somebody notices. There are actually two types of proxy re-encryption algorithms. One is called interactive, where you do need two private keys to generate a re-encryption key, not very useful for us. And the other is non-interactive, when you use private key and public key to get the re-encryption key. You can convert interactive to non-interactive, but anyway, I showed you interactive, which is in this raw form is not very useful for this. We use non-interactive one. So you need typically you need a private key of Alice and public key of Bob. But in the demo, I indeed had private key of Alice and private key of Bob, just to catch attention of some people.
The question is around how do you control for the quality of the miners? My guess is that you're sending them fake data periodically.
Right. Yeah. Yeah. So we're going to send them challenges, and which basically, if you ask to re-encrypt some garbage, it actually will work, but you will get garbage out, and only the creator of the policy will actually know if this is correct or not. So the creator of the policy, Alice, creates something we call challenge pack, where you have multiple inputs and expected outputs. Alice signs all of those and encrypts for Bob. Every time when Bob wants to challenge the miners, he can unwrap this challenge pack and do that. And if the miner responds incorrectly, he can provide the proof to the decentralized network, and then the collateral deposit gets seized, or parts of it. But I'm not sure if it will work exactly like this, because our cryptographer in Malaga came up with something which can verify the correctness of re-encryption without creating this challenge pack. So we are evaluating this. So it will be either with challenge pack or without it.
And do you have a ranking system for the proxies, or are they all equal and the distribution?
Yeah, they're all equal and distributed proportionally to the stake. We do think that maybe it makes sense to have some sort of web of trust or something, but yeah, right now it's just proof of stake.
Quick question for you. First of all, what chain will you be launching this on?
Right, so all the consensus will be happening on Ethereum blockchain, and the token will be ERC20 compatible token. So basically, when it's staked, the nodes will need to, we call them Ursulas, by the way. The nodes are like Alice, Bob, Ursula. So these Ursulas will have to run daemons and also send the ERC20 tokens to a special mining contract, which tells the network that this particular node, this particular Ursula is mining, so so she accepts re-encryption keys, she does re-encryption, and she is responsible for like anything she could do wrong.
And when is your ICO?
So this is, I think, most probably the end of January. But we will announce the exact date in December.
On our Discord.
Yes.
Yeah. Anyway, so if you want to know the precise date, you just can subscribe to our mailing list.
So once the data is decrypted and it's at rest,
So you use the token in order to decrypt the data.
Yeah,
right?
you use the token to make it decryptable. Well, use the token to create the policy first, right? This is one way. We actually want to make it in two ways. Either Alice spends tokens to create the policy, or Bob pays tokens when he makes data decryptable by him. The problem with the second one is that that probably requires micropayments with ERC20 tokens, and that is something which is not fully developed yet. So we decide to start with the first one when the creation of the policy is prepaid with the token, and then in this model for the decryption you don't have to spend tokens.
Right, because when it's at rest, like once Alice receives it and she views it and she uses it, but then tomorrow maybe she needs to look at it again. She has to
Oh no
spend
no.
another-
So for the in this first model, Alice when Alice encrypts data and stores somewhere, she doesn't use the network yet. So it's like completely free, but as soon as she wants to share data with somebody who has a completely different key, then she creates this policy and deploys the re-encryption key with the network. That's when Alice pays, right? And then when somebody somebody reads the data, they don't pay, right?
Okay.
And also Alice, I think Alice can, also can revoke access before the expiration time, and then she will get some of the tokens refunded. They're like unused tokens, but yeah, that's kind of the current thinking.
Can Alice set a policy in terms of how many times I can look at the data as somebody who she shared it with? So maybe I can only see
yeah.
it once.
Well, if you
Yeah.
want to share it with yourself, sure, like with your other devices. You can use your own key to read your data without any sharing. But if you want to, let's say, for like improving the security, to share data with your like laptop, your mobile phone, something else, you can certainly do that, and then you can use the decentralized network.
I was thinking more in terms of kind of like medical records or credit card records.
Right. Yeah.
That you have the you have the need to actually share with a lot of partners, but you don't necessarily want them to access it all the time.
Yeah. You can set the schedule on the policy, like when they can access, or you can share like for a very short time and put that time in the policy. or maybe more relevant for selling the content online, you can share on the condition when it's paid. But for medical records, I guess you just do the time limits.
When do you expect it to be available for commercial use, let's say for medical records?
Well, you can either use the decentralized network, and that's what we've seen with these three companies, because there is nobody responsible for the data. But we certainly can allow some company to deploy this network in a federated manner, or even having a central server doing the re-encryption, and that would work either. In fact, we actually do this kind of arrangement with one large financial company in New York.
How do you compare what you're doing with what blockstack is doing? Where you can move data to different identities and have sort of an approach perhaps that way.
Sorry,
Are you familiar with blockstack?
Blockstack?
Blockstack.
Yeah, but blockstack I'm a little bit familiar with, but
Okay.
not really much.
Okay.
So if you,
I was thinking there's some certain similarities, and I was wondering if you could compare, but it's okay.
okay. I guess after this we can talk.
So you don't think you're similar, is what you're saying?
Can you describe when you would want to use the interactive algorithm when you'd want to use the interactive algorithm with two private keys? What would be an example?
Yeah, there is one practical example when the interactive is useful. It's when you want to do key rotation. So when you change your own key and you don't want to download everything, you just want the decentralized network to change the encryption on all your stuff. That's when interactive is useful.
Are you familiar with Enigma project?
Yes. They do, well, at least originally, in their white paper, they wanted to do multi-party computation. And this is actually one of our advisors, Dave Evans. He is a specialist in multi-party computation. The problem with multi-party computation is that it's very slow. So it requires a lot of bandwidth use. For like a simple operation, like, summing up two numbers or something, you sometimes need to exchange like gigabytes of data. And for something complex, it becomes like completely unbearable. But even if you overcome that, then there is another problem. If you have the 50% attack happening in multi-party computation system, it exposes the plain text data. Like if somebody takes the majority of the nodes, they just can decrypt the data. In our case, if this happens, they can make misapply the policies. Like they can say, okay, instead of limiting this by time, we make it unlimited, right? But if you didn't share data with somebody, it cannot be shared. The nodes themselves cannot decrypt. So their failure mode is a little bit worse, and well, the performance is worse. But it's actually a pretty interesting direction still, because you might be able to make something like smart contracts which work on private data using without exposing it, using these sorts of techniques like multi-party computation. And I think homomorphic encryption is kind of to the same direction. So, but to me, it looks like multi-party computation and homomorphic encryption are kind of competing towards making it possible to compute over private data, but it's still for both of them not yet practical.
So you already mentioned a couple, but what are some of the other risks and threats that you guys are looking at and thinking of addressing? And you mentioned a couple. some of the risks and threats that you
Right,
mentioned in your
right,
white
right.
paper that you can share?
Yeah, so the risks are basically associated with what if the nodes, what if individual nodes become malicious, what if they collude with some some either state actors or whoever pays. And basically we try to mitigate these kinds of risks. One of the way we want to apply, maybe after the launch of the network, is putting some honeypots in the data, so that if somebody decrypts that, they could get actually money from this honeypot, because it could be like, a private key for some honeypot wallet. And but as soon as this transaction happens, you know that that particular node actually misbehaved, so that's you kind of caught it. But that's kind of something which will be applied later on down the road.
For those of us who are interested in the ecosystem that may come out of this network, do you guys have ideas in terms of how people may build on top of this network and add value, whether that be on the security side or even other interesting sort of intermediaries between some of these particular use cases? Has that come up?
Oh, yeah, sure. So even if people want to contribute.
Yeah. Well, also, so you're going to have exchanges where people can buy and sell these tokens.
Yep.
Are there other, sort of, ecosystem type functions that folks can come into and participate and do, or may want to do? You talked about the honeypot example. Some of these things.
Yeah. So I guess the thing we are probably most interested in is helping out to build some client libraries in different languages. We do see some help coming up with that, but I guess, well, this is all written in Python, and we will also need JavaScript and Go libraries. So we have the company called Walk. They want to help out with the Go library, and with JavaScript. I guess we're probably okay for now with that. But if somebody wants to help with that, we certainly would do. And yeah, so I guess maybe helping out with client libraries is the first most important step. Yeah, we're obviously looking to partner with as many companies as we can to enable them to encrypt the data or to make available for the developers. Maybe like maybe actually having it as a having it used inside something like blockstack makes sense. So yeah, and that's probably summarizes.
Are you hiring?
Not right now.
Wait, hold on a second. Are you sure?
Well, not right today, because when you scale the team too quickly, you might become you might become like Microsoft too quickly, like too ineffective.
I thought you guys were hiring for a community manager?
Yeah, for community manager we do hire. That's
so
true.
You are hiring?
We are hiring, but we are hiring a community manager, okay.
So if somebody's looking for a job as a community manager, they can?
Of course.
Talk to you.
Yes.
Yes. Good. Any other questions? All right. Nelly, is that it? Okay, guys, let's give it a round for Michael Egorov and NuCypher.